In this video, we're going to talk about Boyle's law. So what exactly is Boyle's law? Well, let me give you an illustration first. So imagine if we have a column where the volume can be adjusted. And let's say there's some gas particles inside of it. So I'm not going to put too many, maybe like 7 gas particles. Now let's say if we apply a force to compress this container in order to decrease the volume. So now the volume is greatly decreased. And we're still going to have the same 7 molecules. So now, what can you tell me about the pressure inside of this container? Is it greater or less than the pressure in the first one? So in this container, the volume is relatively high, and here the volume is low. So as we decrease the volume, what happens to the pressure? Now notice that in this container, the particles are more spread out, and so they collide with the walls of the container less frequently. Here, all the particles are bunched up together. There's not much space between the particles, and so they collide with the container more frequently. And it turns out that the gas pressure is proportional to the number of collisions. So therefore, the pressure is higher in this container, and it's lower in that container. And so this is the basic idea behind Boyle's law. Pressure and volume are inversely related. If you decrease the volume, the pressure will increase. And likewise, if you increase the volume, the pressure will decrease. So the pressure of a gas inside a container, given that if temperature is held constant, is dependent on the volume. If you decrease the volume at constant temperature, the pressure will increase. If you increase the volume at constant temperature, the pressure will decrease. And that's Boyle's law. Now the equation that is associated with Boyle's law, you need to know what it is this equation. P1 times V1 is equal to P2 times V2. So this is the equation that you're going to use when solving volume and pressure problems. Now you need to know the shape of the graph that is associated with Boyle's law. So let's say if we plot pressure on the y-axis and volume on the x-axis. We know that as the volume increases, the pressure should decrease. Now, do you think the graph is going to look like this? It's not going to be a straight line. Rather, it's going to be a curved line. As the volume increases, the pressure will decrease like this. So that's the correct shape for this type of problem, or this type of law. You might see this in a multiple choice practice test. You might be given maybe 4 or 5 graphs and need to know which one is associated with Boyle's law. So make sure you know the shape of this graph. Now let's work on some problems. Number 1, a 2.5 liter container has a gas pressure of 4.6 atm. If the volume is decreased to 1.6 liters, what will be the new pressure inside the container? Well, let's make a list of what we have. Not sure what just happened there. So V1, the first volume, is 2.5 liters, and the pressure that corresponds to that volume is 4.6 atm. Now the volume is decreased to 1.6 liters, so that's the new volume, V2, and we're looking for the new pressure, P2. So all we need to do is use this equation. P1 V1 is equal to P2 times V2. So P1 is 4.6 atm. V1 is 2.5 liters. Our goal is to calculate the value of P2, and V2 is 1.6 liters. So 4.6 times 2.5, that's 11.5. And that's equal to 1.6 times P2. So now, to solve for P2, we got to divide both sides by 1.6. So P2 is 11.5 divided by 1.6. And so that's about 7.19 atm. So as we can see, in line with Boyle's law, you should always check to make sure that this answer makes sense. We decreased the volume from 2.5 to 1.6, so therefore the pressure should increase from 4.6 to 7.19. Now let's move on to number 2. The air inside a flexible 3.5 liter container has a pressure of 115 kPa. What should the volume of the container be increased to in order to decrease the pressure to 625 torr? So once again, let's just write out what we have. P1 is 115 kPa. V1, that's 3.5 liters. Now P2 is 625 torr. And our goal is to calculate V2. Now, what you need to realize is that P1 and P2, they should have the same units. Now, P doesn't have to always be in ATM. It can be in torr, it can be in kPa, it can be in millimeters of mercury. However, these two units have to match. So if P1 is in kPa, P2 should be in kPa. If P2 is in torr, then P1 should be in torr. It doesn't matter which one is which as long as they match. So I'm going to convert P1 into a torr value. So we need to know the conversion between kPa and torr. 101.3 kPa is equal to 1 atmosphere, which in turn is equal to 760 torr. So this is the conversion factor that we need. So I'm going to put 101.3 kPa on the bottom in order that the units kPa will cancel. And so I'm going to put 760 torr on top. So it's 115 times 760 divided by 101.3. So this is equal to 862.8 torr. So that's P2. I mean, not P2, but P1. So I'm just going to write that here. So now, these two units match. So at this point, we can now use the formula. P1 V1 is equal to P2 V2. So P1 is 862.8 torr. V1 is 3.5 liters. P2 is 625 torr. So now we're going to get V2. So notice that the units torr will cancel, which means V2 is going to be in liters. So to get the answer, it's going to be 862.8 times 3.5, and that's 3019.8. So that's equal to 625 times V2. Now let's divide both sides by 625. So V2 is 3019.8 divided by 625, which is 4.83 liters. And so that's the answer. So notice that the volume was increased from 3.5 to 4.83. So this caused a decrease in pressure from 862.8 to 625 torr. Now let's work on this last question. The volume of a gas at 17.5 psi decreases from 1.8 liters to 750 milliliters. What is the new pressure of the gas in ATM? So right now P1 is in 17.5 psi. It's in pounds per square inches. So when we get our answer for P2, it's going to be in the same unit. And then later we can convert it to ATM. V1 is 1.8 liters, but V2 is in milliliters. So we need to make sure that these two matches. So I'm going to convert milliliters into liters. Now the conversion factor is that 1,000 milliliters is equal to 1 liter. So we just got to divide it by 1,000. 750 divided by 1,000 is 0.75. So V2 is 0.75 liters. So now that V1 and V2 share the same unit, we can now use the equation. So P1 V1 is equal to P2 V2. So P1 is 17.5 psi. V1 is 1.8 liters. We're solving for P2, and V2 is 0.75 liters. So to calculate P2, it's going to be 17.5 times 1.8, and then take that result divided by 0.75. So P2 is equal to 42 psi. The units liters cancel, so P2 has to be in psi. So that's our answer. However, we need to change it to the right unit. So what is the conversion factor from psi to ATM? 14.7 psi is equal to 1 ATM. That's the conversion factor that we need to use. So starting with 42 psi, we can say 1 ATM is equivalent to 14.7 psi. And we need to write it in such a way that the unit psi will cancel. So it's just 42 divided by 14.7. So the new pressure is about 2.86 ATM. And so that's the answer.